In the diagram below, the area of the trapezium ABCD, so ABCD, the yellow trapezium, is equal to the area of the trapezium ABEF, so the pink trapezium. Explain why the length of CE, so CE, is equal to the length of FD, FD. Okay, so what I'm going to do is draw a dotted line from D right the way across, and I'm going to break the trapezium up into different sections. And I'm going to label the different sections X, Y, Z and H. So I'm going to label this distance from here to here as X, and likewise on the other side from there to there as X. So we can see X there on the left, and X there on the right, X there on the left, and X there on the right. Then the distance from here to here is Y, likewise on the right, that's Y. So from D to F is Y, from here to here is Y, from D to F is Y, from here to here is Y. And then this distance here is going to be labelled as Z. So from here to here is Z. And this top distance will be labelled as W. So from here to here is W. And obviously then this entire distance is going to be X plus Y plus Z. And this entire distance can be X plus Y. So this distance from here to here will be X plus Y. And then the perpendicular distance between the parallel sides is going to be H on both diagrams. So here is our parallel lines from D to A and from C to B. And here's our parallel lines from F to A and from E to B. Okay, so the formula for the area of a trapezium is the sum of the parallel sides divided by 2 multiplied by the height, or you could say half multiplied by the sum of the parallel sides, also multiplied by the height. So I'm going to go with the formula for half multiplied by the sum of the parallel sides multiplied by the height. So let's start with the area of ABCD, so the yellow trapezium. So it's going to be half multiplied by the first parallel side, which I'm going to call X plus Y, plus the other parallel side, which I'm going to call X plus Y plus Z, all multiplied by the height, which is just H. So X plus X is 2X, Y plus Y is 2Y, we've just got the one Z, so we get half times 2X plus 2Y plus Z is all multiplied by H. Next, the area of ABEF, so the pink trapezium on the right here. So same formula, so it's going to be a half multiplied by the first parallel side, which is X, plus the second parallel side, which is going to be X plus Y plus Z plus W. So X plus Y plus Z plus W, all multiplied by the perpendicular distance between them, which is H. So X plus X is 2X, we've still got the 1Y, the 1Z and the 1W. So it's going to be half times 2X plus Y plus Z plus W, all multiplied by H. Now we're told in the question that both trapeziums, the areas, are equal to each other. So the area of ABCD, the yellow trapezium, is equal to the area of ABEF, the pink trapezium. So this is going to be equal to this. So we get a half times 2X plus 2Y plus Z times H is equal to a half times 2X plus Y plus Z plus W times H. So now we can start to cancel some things out. So I'm going to cancel out the half on both sides and the H on both sides. So we're left with 2X plus 2Y plus Z on the left of the equal sign, and 2X plus Y plus Z plus W on the right of the equal sign. Now we can do a bit more cancelling. The 2X's will cancel out and the Z's will cancel out. So we've got 2Y is equal to Y plus W. I'm going to bring that Y over the equal sign, it becomes minus Y. 2Y minus Y is Y. So we get Y is equal to W. So let's have a look and see what was Y. Well, if we have a look in our diagram, this distance here is Y, which is DF. So we have DF, and that's equal to W, which is this distance up here, which is EC, or CE. So we have DF is equal to CE. which is exactly what we were asked to show. Part 2. Deduce that the distance from A to G is equal to the distance from G to B. So we already know from the question that the area of ABCD, so ABCD, is equal to the area of ABEF. ABEF. So we can actually break down the shape ABCD, so ABCD, into this green shape and the yellow shape added together. So ABCHF is ABCHF is this green shape, and then DFH is this orange triangle. So the two of those added together give us the shape ABCD. ABCD. The two of those added together, the green shape and the orange shape, give us the shape ABCD. Likewise, we can break down the shape ABEF, so ABEF, into the green shape and the purple triangle at the top. So we have the green shape and the purple triangle at the top gives us the shape ABEF. So we have ABCHF, ABCHF, the green shape, and then the triangle at the top, CHE. So the area of the green shape plus the area of the orange triangle is going to be equal to the area of the green shape plus the area of the purple triangle. So we can cancel out ABCHF on both sides. So that leaves us with the area of DFH being equal to the area of CHE. So since DFH and CHE are both triangles, we're going to use the triangle formula for area, so half times base times height. So for DFH, for this orange triangle, it's going to be half times base times height, so half multiplied by DF, which can be the base, multiplied by the height, which is going to be H1. So this is going to be our height, H1, at the bottom here, which matches up with AG. And for a purple triangle, so CHE, we're going to use the same formula, half times base times height, so it's going to be a half multiplied by CE, which is going to be the base, multiplied by the height, which is going to be H2. So we're going to call this H2, so it's really the distance from G to B, that's going to be the height. So we can cancel out the halves on both sides, and since we know that DF is equal to CE, so DF is equal to CE, we already worked that out in part 1, we can cancel those out as well. So we're left with H1 is equal to H2, and H1 we know is AG, and H2 we know is GB, so AG is therefore equal to GB, which is what we were asked to show.